Hi friends, back with another video. In this video, we are going to learn the build a stable model for HECRAS. So it would be a video series. So the video series we would have the several issues which is quite often we faced in the in setting up the stable 1D model in the HECRAS. Part 1 is the setting up of normal depth. So this normal depth boundary condition is most widely used boundary condition in the HECRAS modeling in both study and unstudy modeling, making the assumption that the flow is passing through normal condition in the downstream boundary. So that is the normal conditions is that means the flow is at steady uniform on the downstream. So the normal we mostly use this normal depth boundary condition because in the large stream or large stream which is ungauged or a streamlet, so there is a high possibility of the availability of the gauge data, either it may be flow or a stage discharge data on the upstream, but there could be unavailability of the gauge data on the downstream. So in that case we need to make some assumption. The assumption is that so the flow on the downstream boundary would be under normal condition, that is making the assumption that the flow is at the steady uniform condition on the downstream and the flow depth belongs to normal depth. So if I illustrate that uh, here, so suppose this one is the stream flowing from upstream to downstream, and the upstream, so we have this the flow hydrograph having discharge q. So at the downstream we don't know the gauge, we don't have the gauge data, so we are making the assumption that the flow is at the normal condition, that is steady uniform condition. So for this condition we need to solve this by applying the Manning's equation. So for that Manning's equation requires the slope, that is the energy slope. So we can measure this energy slope. We need to assume this energy slope so that it can solve for Manning's equation. So that it can solve for Manning's equation and find the corresponding normal depth based on this the energy slope. So based on this energy slope, by solving the Manning's equation, so it will find the corresponding area, perimeter and hydraulic depth for the corresponding discharge D, that is assumed discharge. So thereafter it makes the iterations so that the discharge which is guessed is equals to the discharge which is actually flowing. So this one is the mechanism involved in the assumption of the normal depth in the HECRAS, so which solves uh, the Manning's equation, so for the steady uniform flow on the downstream boundary. So in the HECRAS we can set up this the energy slope by making the assumption that we can make this by measuring the average slope. So if I use the highlighter tool, so if I use that pen tool, okay, so measure the average bed slope of your stream in the profile plot. So you can use the control. So if it is a stream, so if it's somewhat like this, so we will measure the slope for each point. So these are the stations. These are the stations. So I call it 1, 2, 3, 4. So at each point measure the slope. At each point measure the slope and take the average. Take the average slope of it, and in HECRAS you will get this as dy by dx by directly uh, using the key, that is control key in the HECRAS. So you will get the dy by dx, average dy by dx, which is nothing but the normal depth. Normal depth, that is the energy slope. So there are another method which is similar. Suppose this one is this one is the this one is the channel having the steep or a mild slope, and the downstream is something like this. So that is the downstream boundary is in the, either it is in mild or a steep slope. So that means there is no, so at that case you can measure the bed slope of last two. So this one is the last two stations, and you can measure the bed slope of last two station and take average of this. So this method is only applicable only when the downstream boundary slope are either mild condition or steep condition. So we can't use the second point for the adverse slope or the horizontal slope. Suppose this one is the downstream, and here. So this one is the, there is adverse slope at the downstream, or so something like this. So this is the horizontal. So if there is the downstream boundary is horizontal, having horizontal slope or the adverse slope, we can't use the second method. In that case we can use the first method. So for the first method we need to find the slope at for each station, and that is slope nothing but dy by dx. We can directly get that in HECRAS, and find the average dy by dx, which is nothing but the energy slope for the normal computation of the normal depth. So let's move to the HECRAS and compute that normal depth slope, that is the energy slope. So in the HECRAS, so I have already set up the project and defined the geometry, but didn't define the boundary conditions, and I need to assign the normal condition. So before that I need to compute this boundary condition. So for that you need to move to view profile. So if you look at the last two boundary condition, last two downstream boundary station point. So this one is the on the, if you take these two, so here to here. So the first one, the first station is on descending gradient, and the second one is on ascending gradient, that is the which indicates the downstream boundaries on the adverse slope. So we can't directly use the second method, that is just taking the average of this last two cross section. So that method we can't use. We need to use the first method, that is taking the average slope of each cross section. So we can do that average bed slope of each cross section by by pressing the control key. So if you press the control, so you will get this the plus mark icon here. So I I select that point and to this point, and okay, so you will get the slope uh, of this bed on the cross section. So this one is the dy by dx, so this one we can use as the slope. So uh, so copy that and do the same process for the every slope, for each slope. So this one is for each slope, measure the dy by dx for each slope, dy by dx, measure each slope dy by dx for each cross section, sorry, for each cross section measure dy by dx, so you will get the dy by dx. Do it till the last cross section, continue the process and do this for till the last cross section. So this one is dy by dx. So add all that dy by dx of the each cross section and take the average value of this, take the average value of this cross section. So which one is the energy slope, and that is the average value of the cross section bed. So this one is the take average of this, and this one is the final energy slope for the normal depth. So this one is the final value for the normal depth. Close that, copy this one and edit unsteady flow data in the normal depth, copy that value, sorry, the paste that value, paste that value, okay, save unsteady flow data, save your project, move to the computation of the unsteady flow and compute. So it takes few time to run the model. So finally we build the stable model. So that is, they finish the unsteady flow simulation. So there is no errors, so this model is stable. So finally we made it by assuming the right value of the normal depth slope. So if I run that model here, again move to view profile. So if I run the results, so this one is the simulation part, so this one is the results. So we built the stable model by assuming the right normal depth slope for the HECRAS 1D unsteady flow simulation model. Thank you for watching.